Alright, so for this first one, so some of you do this a little differently, but not that there's a right or wrong way. You may have started this off by dividing A to everything, or subtracting by. Either way, the end goal you'll get, roughly about the same thing. I'm going to set this up by subtracting by B. Why? This one is supposed to be an X.
You can see how the BY has to stay together. When you got a multiplication between they don't, the only way you can separate them is by division. They stay as a unit. BY, when you move it by subtraction and addition, they multiplication of a whole number and a variable, they stay together, they're buddies. That was a team.
And then I could divide both sides by A. Some of you had this separate, like A over A. And really, because this is the same thing as what I just had. But instead of writing it twice, unless it needs to be simplified, just write it as one whole fraction. So if you started off the other way, dividing everything by A, you would have got something that looked like what I just had. At the end, just combine it as one fraction. How did we solve number 2 for B? Okay, I was going to say there are 2 different ways you could have went about this. You could have subtracted y and then had to deal with that negative b, or you could have added b, but then you would have had to also get rid of the mx on the other side. So if we subtracted y, we have negative b equals mx. That's why I'm thinking. There's really a negative 1 in front of that b, so we need to get rid of that by dividing it to everything. I'm separating out this negative 1 because I can change the sign of each term. So these would cancel and just become a positive b. This would make this a negative mx. This would make this a positive y. Questions on that one?
Would you be okay if they just left the negative 1, just like the other where you have mx minus? Just have the negative 1 in the denominator, 1, negative 1.
Oh, like this? Were you saying like this? The mx over negative 1?
Yes.
So I would say simplify if you can, and that's something you could simplify. That mx over negative 1. Now, if it was like a different variable, then that would be different. Right, how do you if you added b instead of subtracting, it would look something like this. So y equals mx plus b, that should look somewhat familiar. And then you have to get rid of mx on both sides. It would look a little different than this. They're switched, but I could always rearrange it as well to make it look identical. So you could have done that either way. Yes, I use the symmetric rule to switch it. Actually, symmetric rule, the b would have been on this side. This was just the to solve 3 for b, was anyone able to solve that one? No.
So I
I multiply m on both sides. And I got, yeah, stop you for 1 second. If you multiply m on both sides, it's not going to get rid of this m. It's just going to make 2 of them. We could, however, multiply both sides by v to get v out of that fraction. My goal is still to get v by itself, so I could then get rid of this d. So sometimes you have to do things with the variable you actually need to get it by itself. Questions on that one? This last one, if you tried the delta math, the literal equations delta math, this one was very much like some of those problems. And yes, it is a word problem, but all of the words are really pointless. It gave us the formula. All of this is telling what all of these things mean. I don't really care about all of that. I just need to know what I'm solving for. So I can skip all those words. They're not really that important. They're just there for fun. And so in this case, you kind of have to think about this as usually when you're distributing something. So, for example, if I were to distribute this 4, I'm multiplying it to everything inside. So now each term has a piece of that 4 from the outside. I see 2 of the c's here, and I need to get them both out. So I'm kind of going to go back and undo that distribution by factoring. You may or may not remember that. I see that these both have that c, so I'm going to factor out a c, which in a sense is like dividing it out, but not at the same time. It like makes sense and doesn't make sense. When I factor it out, I'm really just trying to get it back out in front of the parentheses. But in order to factor it out, I kind of have to divide both of these terms to see what's left. So if I divide c and c, I'm left with 1 and just r. I'm trying to undo that distribution. Now I have this 1c is by itself, and if I wanted to get that by itself completely, well, it's almost by itself, I should have said. C is being multiplied to these parentheses. I can divide both of these sides by 1 plus r. To just get c by itself. So when I give you the quiz, you won't have questions this hard. They'll be like the questions we did in class, like the ones we did together. Okay? So don't feel too stressed about that. No. So this 1.1 is your solving multi-step. The 1.2 is literal, but they'll be as easy as the ones we did in class together. Right? When we come back from lunch, you're going to grab a calculator. If you need your calculator number again, you can come up to me and ask. You're also going to put your cell phone in that calculator pocket. Not in your pocket, not in your book bag, or whatever else you have on you, but in that pocket. Unless you're going with Mr. North. And then what I'm going to do is give you the quiz. You'll take it. When you finish, you're going to raise your hand, and I'll repeat some of this when we come back. You'll raise your hand. I'll come around and check it. If I don't highlight anything on your paper, then I'll take it, and you did fine. If I highlight anything, you now have a chance to fix it, and then keep calling me back until it's completely fixed. And you'll have the entire class to do that process. Any questions on that? If I need to repeat that or explain that again when we come back, I will. This bell's gonna ring here soon.